So let us look into the canonical LR, or sometimes we call it the LR1 parser. Actually, it is a parsing technique in which the lookahead symbol is generated while constructing set of items. Now the value 1 in the bracket indicates that there is one lookahead symbol in the set of items. The significance of the symbol is that the parser can decide the reduction based on the k lookahead symbol. So that means what? We can decide the reduction based on the first one, that is 1 in this case. So the steps is, it is similar to the steps of the SLR. Construct the canonical set of items along with the lookahead symbol, build the canonical LR parsing table, and then parse the input string using the canonical LR parsing table. So these are the three basic steps which are there. Now the algorithm is also similar. The only thing we have to see is the closure. First of all, we have to add the augmented grammar, that is, if there is a grammar G, so if there is a grammar G which has S as the starting symbol, then we can add S dash derives dot S at the stop. That will be the augmented grammar. The closure is the same as before. So if you see the closure, how the closure was calculated, the closure, the go to, how it was calculated for the SLR, it is the same, exactly same. The only thing is the closure function can be computed by the following rules. For each item A derives alpha dot x beta comma A. So if you see here comma A, this is the lookahead symbol, and a rule x derives gamma, and B belongs to first of beta A such that x derives dot gamma and B is not in I, then add x derives dot B dot gamma comma B to I. So this is, we'll be looking at this, we'll understand this in a while. Now similarly is the go to function also. We just have to use this. For each item A derives alpha dot x B beta comma A is in I, and there's a rule x derive alpha x dot beta comma A is not in go to item, then add A derives alpha x dot beta comma A to go to items. This process will repeat until no more items can be added to the collection C. Now let's take an example. Here I have a grammar S derives CC and C derives AC or D. So you can see that the non-terminals are C and S and the terminals are A and D. The augmented grammar is added at the top. S dash derives S as per the rule, which was rule number 1, which was set. Now we'll look at the solution for it. So let us see the first line. If you see the first line is S dash derives S, and there, that means what? There is a continuation for S. You can see that continuation of S is S derives CC. So S derives S and S derives CC. So let's understand that. Now S dash derives, we add dot first in the beginning and dollar. Now dollar is added in the beginning to initiate, say that the lookahead symbol is a dollar. We can, the initial stage is always a dollar. Now we follow the rule as per the rule which says that A derives alpha dot x beta comma A. So here also we'll say A derives alpha dot x beta comma A for this rule. So dot S, that means dot x. So you just compare this dot S and dot x. That means S is x, alpha is epsilon, dollar is A. So you can see that the A is S dash, so A is S dash, alpha is epsilon, x is S and beta is epsilon, and A is equal to dollar. So if you see that, since the rule says that if there is a production, if you look at the rule again, it says that for each item so and so, and there's a rule for x, that is, it is extending, x is extending forward, that is x gamma. So you can notice here there is an extension, so S is extending to S derives dot CC. So that means what we can do is we find the B for it. B belongs to first of beta A, so that is the rule. B belongs to first of beta A. So we have to find that first of beta we know already it is epsilon. A we already know this is dollar, so we just say first of epsilon dollar, and epsilon dollar is always dollar, so beta is equal to first of dollar, so beta is equal to dollar. So in such cases we add s derives dot cc dollar will be added to I0. So you notice in I0 you can see that s dash derives dot s comma dollar and s derived dot cc comma dollar. And similarly, if you see dot cc, there's an extension. Let's look at the grammar again. If you see s derives cc, so c there's an extension. C can be ac and c can be d. So there are two extensions, so c can be ac and c can be d. So similarly here also you find a first of beta for this. So b belongs to first of beta for, so before that you just find dot cc. So you can see that dot is, compare this dot with this dot, that is dot x and dot c. So c is x, the alpha is epsilon, beta is c, and beta is the capital C, this is beta, and a is the dollar sign. So there is a production for it. So we find b belongs to beta of first of beta A. So if you see beta is what? C, and A is what? Dollar. So C dollar. So C dollar means you take only the first one, that is first of C. Now first of C, if you look at this, it is always, the first of C is always A and D. So you get the first of C is A and D. So B is equal to A and D. So we can write that C derives dot AC, C derives dot AC, we can write the lookahead symbol is A oblique D. So we have two lookahead symbols, A or D, so we can write A oblique D. Similarly, the calculation for C dot D will be the same. So you can say that C derives dot D will be A derive D. Now once we finish this, now let us look at the production of this. If you look at the production of this, now if you say s dash derives dot s, so this dot should jump forward, so it should be s dash derives s dot. So we say go to s, or go from I0 to s will give you s dash derives s dot comma dollar. So that is what we have done to have here. Similarly, in this case we apply the goto on C in I0. That is how the calculation is done. So if you see the calculation for the next one, that is s derives dot cc, this dot c will apply, that it will become c dot c. So you can see c dot c dollar added to I2. Now as after the dot comes, we will add the rule of C. So we'll add the rule of C. Now x is equal to C, beta is equal to dollar, epsilon, and E is equal to dollar. Again remember, this is the rule, A derives alpha dot x beta comma A. So we can say that x derives dot gamma comma B, where B belongs to first of beta A. So we will say that C, if you notice that again dot C is there, dot C, there's an extension for dot C. C derives dot C. If dot C, that means that the extension C derives AC and D. So we have C derives AC first of all. So we have find a beta, B belongs to first of this. So repeat this process, you'll get C derives dot D. So you get B belongs to first of dollar. So in this case you can have that. In I2 you can have that C derives dot AC dollar and C derives dot D dollar. Repeat the same process for all the others. All the others means we have finished the first line, we have finished the second line, then repeat the process for the third line. C derives dot AC oblique AD will give you C derives A dot C, A or D. So that gives you this one. C derives A dot C, comma A or D. So it gives you this production. Repeat the fourth line, that is C derives dot D will give you D dot, that is this production. After this is finished, then go for I1, and you see I1 is complete because the dot is in the last. So go for I2. I2 you see C dot CC, C dot C, so you should get C dot, so that will give you a new production again. So that production is given here. For each and every one you have to calculate the look ahead symbol. And finally, these are the full steps which are given. This is the whole steps which are given. And finally, once these steps are given, we have already calculated the closure, the go to, so we get up to I9. Then finally we create the table. The table is very easy, so you can just go through the algorithm, but I'll explain you through an easy process. So this is a summary of what we have. I0 gives you this, I1 gives you this, I2 gives you this, I3 gives you this, I4, I5, I6, I7, I8, and I9. So let us look at the final table. So if you see I0, so let's look from I1. That means go to I0S gives you I1. S is capital, so it is a go to statement. So we can say I0S. So you can see that it is 1. That means from 0 to S it gives you 1. From 0 to C it gives you 2. From 0 to C it gives you 2. From 0 to A it gives you 3. A is a terminal symbol, so it is a shift action. So we can say I0 to A gives you 3. So I0 to A gives you 3. So it is a shift 3. We'll write it as S3. Similarly, I0 to D gives you 4. So it is a shift again, because D is a terminal symbol, so it is a shift, so we say shift 4. So repeat the same process for all the others. Only thing now is we see where is the dot ending. So this is a dot ending in the last. So you can see that S derives S dot dollar. Now that means what? This is a reduce action. Whenever you see the dot at the last, that is a reduce action. So we reduce under the dollar symbol. So under the dollar symbol we reduce it. Since this is the starting symbol, we accept it. Similarly, let's look at another one, that is let's look at this, that is I4. It is D dot. So D dot, it is a reduce action. It's reduced under A and D. So under, if you see I4, let's look at I4, it reduces, we say R3. Why R3? Look at the grammar. This is considered as 0, 1, 2, and this is considered as 3. So it reduced under C derived D. So we say that it is R3. We consider the number, serial number. So R3, R3. Repeat the same thing, go to I5. Let's look at I5. S derives CC dot. So this is a reduce action under dollar. So under dollar we reduce, but this expression is in which line? It is in line number 1. So if you look at the grammar again, it is in line number 1. This is considered as line number 1. This is line 0, 1, 2, and this is 3. So this is line number 1. So we say R1. So we can say that it is R1. So repeat in this process. You get R3 again for 7. If you see 7, C D dot, so it's R3. It is reduced over dollar, and under 8 again is reduced AC dot. This is line number 2. So we say R2 under A and R2 under D. So under A and under D, R2. And then lastly in I9 it is under dollar. This is also 2. So R2 under dollar. So this gives you the parsing table of the CLR. So this is how we construct the parsing table. And if you want to use an example for it, you can always try it out. It's the similar to here I didn't mention about the example, but you can always try it out in the same method as I've explained it in the CLR parser. Now Let's look at the last one, that is the LALR parser. Let's look at the last type of parser, which is also called as the LALR parser. Now the LALR parser has a lookup symbol which is generated for each set of items. The table obtained is smaller in size than LR parser, and the steps are the same as the LR1 parser. So there is no difference between the LALR parser and the LR parser, but the only thing is we have to see is, let's understand it through an example. Now let us look at a few things, that is I3 and I6. Let's look at these two. If you look at I3 and I6, this we have just done in the previous in the LR1 parser. If you see here, C derives A.C, C derives .AC, C derives .D, and here also it's the same. If you see, it repeats the same. The only thing is the look ahead symbol is different. AD, AD, AD. The only thing here is $, $. So what we can do is these two can be merged together. So instead of saying I3 and I6, we can merge it as I36 will make it. That is the meaning of that. So we can see that we can merge the states which are similar. So we say I36. So we say I36 is go to I0 comma A, and we have A/D/$. So we merge the two states I3 and I6. So we just add A/D/$. Similarly, if you look at I4 and I7, is the same thing. I4 and I7, C derives D dot, C derives D dot. This is AD, this is $. So we can say that I47. So we have a new state which is called as I47. Similarly, I89 will be the same. So you can see that the states which are here there are 10 states: I0, I1, I2, I3, I4, I5, I6, I7, I8, I9. 10 states can be reduced to less states. That means 3 states have been reduced. I36, because they have merged, I3 and 6 has been merged, so it becomes I36. I47 has been merged, it becomes I47. I89 has been merged, it becomes I89. Similarly, the table has been merged accordingly. So you have in 0 you have S36, S47. In 1 it is an accepted state, in 2 it is S36, S47. So in 3, instead of 3 and 6, we just write 36, and we say S36, S47, and so forth. So this becomes the parsing table. So you can see that before, the parsing table has 10 states, but now it has 1, 2, 3, 4, 5, 6, 7 states. 3 states has been reduced. This is how the SLR or LALR parser works. So this completes your unit 2 of the parsing table, of the parsing algorithms which are used for syntax analysis.